Hello, everybody. Welcome to the first episode of Hack Summer 21. My name is Michael Taggart, but most folks just call me Taggart. Hopefully, you're in the right place. You know what you've arrived for. This is a gentle introduction to the Linux operating system. We're going to be running this for 6 weeks, starting tonight and every Wednesday at 5 p.m. Pacific until August 11th. So, thank you for tuning in. If you're joining us live, feel free to drop a hello in the chat. If you are joining us recorded, you're very welcome as well. So without any further ado, let's get this show on the road. Hello, Control Byte, good to see you. We have the chat up finally, so your messages will appear on screen. So we are here at session 0. Welcome to Linux. Let's get the music back up, just a little bit of some gentle tunage. There we go. Not too distracting, just enough so it's not just my voice that you're hearing. Mellifluous though it be. All right. Control Byte asks, you may have just mentioned this, but where the session recording is going to be posted? Great question. So they'll of course be here on Twitch. However, they are cross-streamed to YouTube. You can check them out at youtube.com/taggarttech, which I will toss in the chat. So everything's going to be right there. And of course, I encourage everybody to join our Discord so that we can have a discussion before, during, and after these sessions. Feel free to hang out there. Join us. There's a Hack Summer channel ready and waiting for you. And we'll cover some more of this as the course goes on. But for now, let's get started. So this is session 0. This is just a welcome to Linux. So today's going to be a little more info dumpy than some of the other sessions, right? We're going to do a lot of background information, kind of a getting to know you, getting to know me. And then what we're going to finish with today is setting up the Linux virtual machine that we're going to be using for the duration of the course. So that's how we're going to end today. And then we won't set up the challenges until next week. Right, so we'll take that a little bit slow, but we're just going to get started with some background information today. And here's the deal: because we're doing this on Twitch and we have the chat channel as part of the engagement, don't wait to ask questions. Feel free to throw the questions in the chat, and as soon as I get a chance, I will answer them if I can. And if I can't, right, I don't know everything, that's totally okay. I will tell you I don't know, and we'll try to find out the answers together. So let's start first with just a little bit of background about myself and why I decided to do this. So as I said, my name is Michael Taggart. Most folks, though, just call me Taggart because there are too many Michaels in this universe. I mean, it's okay number, but, you know, it's hard to disambiguate them. And I've been a computer nerd my entire life. I don't really think I had much of a chance. There were always broken computers around my house when I was growing up, and if I wanted to get one working to play games on it or whatever else, I had to put the pieces together to make it work. And that was kind of it. Even though I didn't go to school for computers, I got an English degree in undergrad. I've always been fascinated by technology, and so I ended up teaching technology. And I've been a career technology educator since 2008. And I've been working in schools K-12 for most of my career. And I love teaching, which is why I still do this. A couple of years ago, I switched over to cybersecurity, and I do a lot of that work here as well. I'll stream with offensive and also defensive cybersecurity topics. But a big turning point for me in all of this was when I started using Linux in 2010. And just a quick background on that, it was a broken MacBook Pro that made this happen. I static zapped in the depth of Pennsylvania winter a MacBook Pro and killed its logic board. And as I sent it away, I had to use this loaner machine. And I didn't like using Windows on it, so I started using a distribution of Linux, and it kind of just got me hooked. I wanted to learn more and more about the OS, and because of Linux's nature, I was able to learn quite a bit, and it let me play around with it. And I just thought that was the coolest thing, that I could control my computer to that degree. So I dove in and I learned everything possible about Linux. I deployed it, and professionally I started using it in the server room, and also I was even able to deploy Linux on laptops in schools, right, to teachers and students. Deployed it on servers, I've deployed it in the cloud. I learned programming largely as a result of learning Linux, right? Writing Python, writing Bash, all of that was integral to what I was doing just with my computer in general. I ended up becoming a software developer. I have written code for money. I've done consulting, and I have, of course, used Linux the whole time to do so. My main computer every day is a Linux computer. Even on my Windows machine, my bread and butter is in Windows Subsystem for Linux, so I spend most of my day looking at a Linux command prompt, and I love every second of it. I really, really like using this computer in this way, and I love sharing my passion for it. So I'm excited that you're here, and I'm excited that you're excited to learn. But yeah, these days I am a cybersecurity analyst and a pen tester when they let me. I do both blue team and red team stuff professionally and here on Twitch. And through all of it, Linux is my secret weapon. All the tools that I have available to me at the Linux command prompt are what make me effective at my job. So I'm really excited that you're here as well. Giovanni, welcome. Good to see you. All right, moving right along. So let's talk about you for a second. Maybe you're here because you want to learn a little bit more about Linux professionally. Maybe you're curious just as a hobby. Maybe you're an IT professional looking to build your skills. Maybe you're looking to break into IT. Whoever you are, wherever you're coming from, whatever your background is, the first thing and the most important thing that I want you to know is that you are very, very welcome and that you belong. We have a pretty important rule here, which is that we don't have any gatekeeping and we don't have any judgment, right? We are here to share and learn together, and we welcome all skill levels. We make no assumptions about what you've done before, and we're just excited to learn together. That's it. So I know that in IT, it can feel really scary to break into new areas, new communities. And even if you have a background in IT, imposter syndrome can come for a lot of us, myself included. So I just want to put this out here right up front. I want you to feel like you belong and that you have a place here. So you're very, very welcome. In terms of prerequisites for what we're going to do for Hack Summer, not too many of them. First and foremost, a hunger for learning. And if you're here, you're sticking around on this stream, I know that you already have that. So I'm not too worried about you being hungry for learning. Your computer is going to need to have a little bit of horsepower to play along exactly this way. Of course, if your machine can't handle this, that's totally okay, right? We will go over some other options that are available to you if you need to use Linux fully in the cloud or something else like that. But for what we're going to try to do, especially today, we're looking for a machine that has around 8 gigabytes of RAM and around 20 gigabytes of free storage. Jason, thank you so much for the subscription on YouTube. So those are our prerequisites technically, and we're going to be installing VirtualBox. We'll be doing that today together, so we'll walk through that. And we're also going to be using the Ubuntu server ISO. So before we go any further, I want to talk a little bit about that. And because some of the downloads might take a while, you can get those started right now as we go through some of the other background material. So in terms of installation, things that you're going to need, the first place you're going to want to go is virtualbox.org. I'll throw that in the chat as well, virtualbox.org. And you can go ahead and click on that big blue download button. And you'll see installation candidates for Windows, for Mac OS. If you're on Linux already, great. There are installation candidates for your operating system of choice, even Solaris, because it's, Oracle. And pretty simple installation, right? If you need help installing VirtualBox, drop a note in the chat and we can walk through it. I have VirtualBox installed already, so we're going to kind of leave that alone. But it's just a regular application, installs pretty quickly. The second item that you're going to need today is from ubuntu.com. And what we're going to do from Ubuntu is we're going to download the Ubuntu Server 20.04 disk image, which is what we're going to install our Ubuntu virtual machine from. okay? To get there, what you're going to do is from ubuntu.com, you're going to click on download, and we're going to go to Ubuntu server. You can click get Ubuntu server. Now, there are a bunch of different ways to get Ubuntu server, even on a Windows machine. Actually, the built-in hypervisor, the virtualization manager that comes with Windows, has a one-click install for Ubuntu, but that's not what we're going to do. Instead, we're going to do it the hard way, option 2, manual server installation. So go ahead and click there, and you're going to click on the green button, download Ubuntu server 20.04.2. That's going to download about a 1 gig file, 1.14 gigs to be precise. And this is going to be the disk image that we install from. We still have more work to do with that file, but you're going to want to have it downloaded before the end of today's session so that we can install and create our virtual machine from it. As a reminder, if you ever have any questions, feel free to drop them in the chat. I will answer them as soon as I can. All right. So let's talk a little bit about the background of the Linux operating system and how it came to be what it is today, and even what is it at all, right? You may have heard about Linux, you may be a little bit curious, but you don't know all the details, and that's totally fine. But I think the story of Linux is really, really exciting. It's one of the things I most love sharing with folks. So let's do that. So Linux is by definition what's known as a Unix-like operating system, and we'll talk about what Unix is in just a minute. It was created by a Finnish computer science student in 1991 by the name of Linus Torvalds. And he was just doing it as a hobby. There's a very famous post from September of 1991 where he said, oh, it's never going to be a big thing like Minix, which was another Unix-like operating system at the time, but here it is, and I'm toying around with it. Well, fast forward to today, and it is a massive, massive enterprise. Not an enterprise as in a for-profit business, but it is a human enterprise that thousands and thousands of people have worked on, have contributed to, and that manages some of the most important computing processes in the world. An important aspect of Linux and why it works the way it does and why it's so popular is that it is free and open source, meaning it's free to use, modify, and redistribute with some provisions, which we can talk about a little bit later in terms of how open source licensing works. But what's the big takeaway there is that unlike a closed source proprietary operating system like Windows or Mac OS, you can actually take a look at the source code of Linux and understand how it does what it does. And if you wanted to make changes to it, if you had the capability to do so, you can do that and recompile the operating system to suit your needs, and then redistribute it to share with others who may also have those same needs. Also, if you want to contribute to the Linux operating system or other distributions of it, you can do that too. It's fully community driven. Now, there are lots of corporate sponsors these days, and it's a big, big operation. Nevertheless, that open source philosophy continues to drive it, and I think is the core of its success. Linux is used not just on servers, which we'll talk about a little bit more, but also on desktops, right? And all kinds of other devices. So just because you may have a sense of Linux in one use case, but there are Linux use cases all over the place, in places where you might not even imagine. And its flexibility, its pliability comes in part from its open source nature. We mentioned the Unix operating system a minute ago, and Unix-like operating systems. And what does that mean? So the Unix operating system was first developed in 1969, if you can believe it. And it was part of Bell Labs, right? Like Bell Telephone Labs in I believe Palo Alto in California. And Bell Labs is responsible for a lot of innovations that we now take for granted in our computing realities. As a matter of fact, the folks you see in that picture right there, Dennis Ritchie and Ken Thompson, are also responsible, in addition for the Unix operating system, also responsible for the C programming language, which is one of the core programming languages that is in use today. The Unix operating system family tree has some pretty prominent members, including Linux, of course, but also the Berkeley Software Distribution, or BSD, which you may have heard of, which itself spawned things like the Mach kernel, which went on to be known as Mac OS. And of course, we also have things based on Linux, like the Android operating system. So where is Linux today? It would probably be a better question, where isn't it? You know, the plurality of web servers running on the internet today run some version of Linux. And the vast majority of cloud computing instances, virtual machines that are in the cloud, whether it's Amazon's cloud or Google's or Microsoft's, odds are they're running Linux because it works so well as a server and application development platform. Fun fact, 100% of all supercomputers in use today run some version of Linux. It is now heavily used in robotics and the Internet of Things. So if you have a smart device in your home, whether it's from a massive, logistics company or some other kind of, smart speaker in your house, odds are under the hood, there's a Linux kernel in there somewhere. And very recently, just to add to the prestige of the operating system, Linux is now on Mars. The Ingenuity robotic helicopter that was dropped and tested and shipped, of course, with the Perseverance Mars rover earlier this year, runs on Linux. And it's the first time that a kind of commercially available or general computing operating system has been used to operate a scientific instrument, certainly a robotic scientific instrument, off-world. Linux is everywhere, and because of its ubiquity, I would contend that it is the most important software project in the world. If it were to disappear tomorrow, the number of things that would stop working would be truly staggering, or even if it were to go closed source, which I hope never happens. And so, we're going to learn how to use Linux to accomplish our goals. But I think it's important to understand the ecosystem that we exist in that is also using Linux. It is a community. So there are some key terms that you're going to want to know as we go through our exploration of Linux. And I want to make sure that we have these down first before we go any further. The first thing you'll hear very often, and I've already mentioned this a couple of times, is the Linux kernel. And the Linux operating system is more than just the kernel, but the Linux kernel is the core of the operating system. You can think of the kernel as the part of the OS that interacts with the metal. It's not the graphical component necessarily, right? It's not the applications that are developed on Linux, right? But it is the part of the operating system that really works with the low-level computing hardware. It manages scheduling of the CPU. It manages the memory usage. It manages the file system. All of these really, really low-level operations that have to happen in order for everything else for the user's experience to work, that's the Linux kernel. You'll sometimes hear the term, or you may have heard the term drivers, right? Drivers would be those pieces of software that intermediate the interaction between the hardware of a computer and the software, the operating system that is trying to use that hardware. Well, most of those drivers are going to be part of the Linux kernel. But as I said, it's not the whole OS, and the whole OS is also going to have other components to it, especially as it is packaged and redistributed by other organizations. The Linux kernel is, I believe accurately, millions of lines of code long, and the code is contributed by many different people and organizations around the world. These days, you may not believe it, but actually Microsoft and Google are some of the top contributors to the Linux kernel, and it's because they use Linux more than almost anybody. It is still to this day mostly written in the C programming language, even though, as we saw, the C programming language is a little bit long in the tooth. It's designed for exactly this kind of low-level work, and that's why it works very well. And Linus is himself a C programmer, and to this day, final review of contributions to the Linux kernel are overseen by Mr. Torvalds. Giovanni asks, is it also called a kernel in Windows 10 and Mac OS? Yes. If you think about it, the term kernel is part of operating system architecture, regardless of the OS. In Windows, you may have heard the term the NT kernel. I don't know if that's still part of... Yeah, I think Windows 10 did away with the NT kernel, but that is what was basing... was forming the foundation for the Windows OS until Windows 10. Now I think it's just the Windows kernel. But yes, even in Windows, there is a kernel in terms of the architecture, and then other components of the operating system that make up the Windows experience that you're used to. Similarly, in Mac OS, you have the mock kernel that does the same thing. So yeah, the same kernel is almost a term of operating system architecture, right? There are other OS architectures out there. There's a lot of work being done right now in what's called microkernel architecture, where it isn't this one big blob of code that does all this work, but rather smaller modules. But in the case of Windows 10 and Mac OS, it is still a kernel that is forming the core of the OS. You may also see in your exploration of Linux the acronym GNU, which stands for, I'm not kidding, GNU's not Unix. It's known as a recursive acronym. I hate it a lot, but that it is what it is. And the reason that it matters for us is that a lot of the user tools that we are going to be interacting with as we work with the Linux terminal, the command line, are from the GNU suite of tools. And so these are, again, open source, and they're included with the Linux operating system in most distributions, but they are the GNU toolset. They're a separate entity. So in case you see GNU pop up in different, areas or different contexts, I just wanted you to have that as a bit of context for that term. Okay. Next up, and this is probably the biggest one you're going to see and hear a lot about, is distributions. So as we've said, we have the Linux kernel, but when you install a Linux OS like Ubuntu, which we're about to do, that is not the entirety of the OS. Distributions put other software together with that Linux kernel. They'll often customize the kernel, but they put it together with these other software packages, brand it, and offer it out. Now, most of the time offered for free, but not always. Some Linux distributions are licensed. And so a distribution is considered a repackaging of the Linux kernel with a desktop environment so that you can interact with it, although not all of them need a desktop environment, and other supporting software. The other important component of a distribution most of the time is that the distribution will maintain their own repositories of software for updates and new package installations. I want to pause on that idea for just a moment, because it might seem like less of a big deal these days, but when it started, it was a huge concept. Okay, if I want to install a new piece of software on a Mac computer, where do I go? Chat, where do I go most of the time if I want to install a new piece of software on a Mac computer? Or even make it easier, where would I go on my smartphone? Absolutely, Gromit. I go to the App Store. And the App Store serves the same role as these distribution software package repositories. It's just a lot shinier. But the idea came from the way that Linux distributions handle their software. So the App Store is essentially a blessed database of software that you can install. Can you install things from elsewhere? Just go to a website and download it? Absolutely. Right? Or if you're old enough, you remember installing software from physical media, like a CD-ROM or a floppy drive if you're, getting ancient like me. But this blessed database of packages that you can download, right, began with Linux, and that's kind of what part of the responsibility of a software distribution, a Linux distribution, is to provide that database, update it, and allow you to download new packages and update the packages that you have. Josker the Grouch, thank you so much for the follow. Now, distributions tend to have catchy names so that it's branding like anything else. So here are some distributions you may have heard of or even seen a logo for. We have Debian, which is actually the ancestor of Ubuntu, which is what we're going to be using for this course. Arch Linux. We have Red Hat. Red Hat doesn't have a great logo, so I didn't put it on here, but Red Hat I'm going to call out because Red Hat is a commercial Linux distribution. So there is a free and open source version of it called, well, there used to be called CentOS. But Red Hat is interesting because what you do is you pay for support from Red Hat and you get the Red Hat Linux distribution and you can use it in your business. The same is true for the SUSE Linux distribution, this chameleon guy here. There's OpenSUSE, but there's also SUSE Linux Enterprise. So these two are really interesting because they've actually created successful businesses around supporting otherwise open source software. You'll also maybe have heard of Linux Mint or Manjaro. There are a bunch of different Linux distributions, but these are some of the biggest and some of the ones that I've worked with in the past. Most of the time these days, I work in Ubuntu or different spins on Ubuntu, and that's where we're going to focus for this course. But if you're looking to learn your Linux skills professionally, you are definitely going to want to look into Red Hat as well. Thanks for the follow, Giovanni. Really appreciate it. All right, folks, the time has come to get started with our virtual machine installation. So as I said, we're going to use VirtualBox. Hopefully you've had a chance to install it by now. And we're going to use the Ubuntu Server 20.04 release as our base for our machine. But before we go any further, I just want to pause for a moment and just check to see if there are any questions about any of the material that we've covered so far. So we're just going to chill here for a moment in case anyone who's watching does have any questions they want to drop in the chat. And while we're there, I'll toss the Discord link once more. Giovanni asks, what version of VirtualBox? I'm using the latest version, VirtualBox 6. I think it's like 6.1 something. So yeah, you want to get the latest and greatest. You know what? Let's not guess. Let's say, yeah, 6.1.22 is the latest version. So that's what we want to be working with. And while we're paused here waiting for other questions, I do want to call out the Ubuntu versioning convention because, once you see it, it makes a lot of sense. So the way that the Ubuntu server or the Ubuntu operating system versioning convention works is that it's the year, the month, and then kind of the point release, any updates after that. So Ubuntu Server 20.04 was released in April of 2020. And you might think, well, that's kind of old, right? Isn't there a new one? There is. But the reason we're using this is because it's an LTS or long-term support release. So the way that Ubuntu works is that Ubuntu is going to release a long-term support version of the OS every 2 years. Okay, so 2022 would be the next one. And in April is their long-term support release. And they commit to updating that operating system for up to 5 years. And so I really like basing our courses on the LTS just because the course material will be relevant for longer, but also because it's stable, right? They'll test other stuff for the OS in the other releases. So the other month, they release a new version every 6 months. So the October release 20.10 had a lot of new stuff that they were testing, but not necessarily what you'd want to base something, ultra stable on. All right, I think we are ready to get started with our installation. So let's get VirtualBox up and running. It should look like this. And I don't need Kali Linux in the background. There we go. Okay, so we have the VirtualBox window here. It doesn't look like much, and I have a VM already built, but that's okay. We're not gonna worry about that. We're gonna work together to create a new virtual machine. So you can do that from, from this new right here, this button, or Control N, of course. Now, by most of the time, your defaults will be just fine. If you want to change where your virtual machines are stored, you can do that by choosing a different machine folder. But if you don't know exactly what you're doing there, just leave it alone. The default should be okay, right? The default folder will be pretty sane for you. So I'm going to name my VM, my virtual machine, HackSummer21. And I'm going to tell it that it is a Linux and that it is Ubuntu 64-bit. So I'm just going to drop it down. And that has some impact on the way that the VM runs, but also importantly, it gives me a really nice logo that matches the Ubuntu logo. That's really the most important part. Let's talk briefly about the memory. This is the RAM, okay? If you're not familiar with these terms, think of it as short-term memory. This is the memory for ongoing processes on the machine. We want to give it 8 gigabytes. Well, no, we don't. We want to give it 4 gigabytes of RAM, just to be generous with it. Now, here's the thing about bytes. When we use the term byte or kilobyte or megabyte or terabyte, right? We have those metric prefixes on the terms, and so you might think that a megabyte, or let's go with a kilobyte, is 1,000 bytes, and that's not totally wrong, except that the way that computers work is that we work in multiples of 8. And so, as a matter of fact, a kilobyte is 1,024 bytes, which is why you see that 1,024 right here. So if I want to give my machine 4 gigabytes of memory, what I would want to do is say I want to take, if 1,024 megabytes is 1 gigabyte, I want to take 4 times 1024, which is 4096, right? And that's how many megabytes I actually want to give this machine. So you just type that right in, 4096. If you want to use 2048, that's 2 gigabytes. If you can't spare all 8, that's fine. The machine should run okay on 2 gigs, but I like to give it 4 just so it doesn't have any questions about it. Underneath that, it asks about creating a virtual hard disk. When we create a virtual machine on our computer, right, we're creating a sandbox where information is going to be stored separate from our regular operating system. And we have to define the size of that virtual disk. We can grow it a little bit later, but we have to define its starting size. So I'm going to choose Create a Virtual Hard Disk Now and click Create. And here's where I get to choose how large that disk is. I'm going to start it at I'm going to give it 50 gigs, but that's, as we said in our intro, 20 gigs should be sufficient, right? So if you want to put in 20, that's fine. I'll do 30, just so it's not so huge. And we really won't need that much space for this course. But if you want to do other things with the server later, the more space you can spare, it'll be a little bit easier. Now, the hard disk file type, this option down here, doesn't really need to be changed, especially if you're just going to be working with VirtualBox. These other file formats are for compatibility with other Perfect Timing Giovanni, VDI, VHD, VMTK. These are file formats for the virtual hard drive for other what are called hypervisors. So virtual machine supervisors, hypervisors. So VirtualBox is one of them. Microsoft's Hyper-V, which comes with Windows, is one of them. VMware is another. Zen, I could go on. KVM, which is the Linux native virtualization manager. Depending on what you need your compatibility to be, you would choose these different formats. Because we're just going to be working in VirtualBox, we're going to stick with VDI. And we're going to leave this as dynamically allocated, so if it does need to grow, it can. Go ahead and click Create. And here we have a virtual machine. We've just built a computer. Now, just like building a computer in real life, where we order all the parts online and we, have them shipped to our house, and we make our spouses angry for a minute as we put the pieces together and take over an entire room. Anyway, just like that process, the hardware, which is what we've virtualized right now, is different than the operating system itself. The operating system is software, and we haven't installed it yet. That comes next, and that's why we needed to download that Ubuntu 20.04 ISO. That's a disk image. Think of it as a software representation of a CD-ROM or a DVD-ROM. Socialist Maker, good to see you, friend. The ISO is a disk image, and it's what we're going to be installing from. Now, Zoomers, if you're watching, you will have no idea what this is like, but back in the day, it used to be the case that even Linux enthusiasts, but also PC gamers, would buy magazines, and those magazines would come with CD-ROMs, and it was from those CD-ROMs that we installed software. Or if you're going back far enough, it would be floppy disks. Back even farther, there would be code on the pages of those magazines, and if you wanted to reproduce a program, you would have to manually type in the code from those pages, character for character with no mistakes. All right, let's power this thing on and get this thing working. So make sure that you have that ubuntu.iso file ready and you know where it is on your computer, because we're going to be pointing this thing to it. I can double click to start it or just click the start button. Either way, I'm going to be starting my virtual machine. And of course, this window came up on the wrong screen, but that's okay. You're going to see something that looks like this: select startup disk. And this is where we need to set up. We need to basically put that CD-ROM, DVD-ROM, whatever, in the slot. Go ahead and click on that folder icon here, and this is where we get to navigate to select the disk that we want to put inside of this virtual drive. Now I have my Kali Linux ISO already here, but that's not what we're going to be using. We're going to be using that Ubuntu. So I'm going to click add, and I'm going to go navigate to my ISOs folder, and here's the Ubuntu 20.04. If yours was just in your downloads folder or wherever else it was, go ahead and point it there. If you need help, again, feel free to drop a message in the chat, or if you're in the Discord, drop a message in the Discord. Somebody is going to help you out. But, so I have my Ubuntu ISO here. I'm going to click on it, choose open. And now I have that as an option. I will click choose. And now it's selected here. I will choose start. And over here, my virtual machine is booting up. I get the aubergine of Ubuntu. The Ubuntu color scheme is, it's purple and orange, right? But they call it aubergine and tangerine. I guess because they wanted it to rhyme. So we're going through the startup process, right? We are booting the operating system from the virtual disk. We have not yet installed it. It's not installing yet. We are starting up the whole OS right from that virtual disk drive. If you get some errors like that, that's okay. We should see a startup eventually. Now, as you move your mouse over the VirtualBox window, it will disappear. And the first time that happens to you, it might freak you out, which is understandable. But it's because at this stage, first of all, if there were a mouse cursor that was functional, it would change and you would be moving your mouse inside that virtual computer. But at this stage, it's all terminal, baby. There is no mouse whatsoever, right? This installer is pretty old school because it's a server installer. It's really not meant to have a monitor connected to it after the installation is finished. But we're going to work through it this way. So I've clicked into my VM, and if I use my arrow keys now, you can see that the options move around. So this is where you're selecting your language. I'm going to choose English. If you're in the UK, go ahead and choose English and UK, and add extra U's and stuff to your words if you want. That's cool. And I'm also going to use the US keyboard layout. The next thing that should happen is that your virtual machine is going to pick up an IP address, and we're going to talk more about IP addresses and how they work later in the course. But it should look something like this: ENP0S3 with an IP address of 10.0.2.15/24. We will talk about what all of that means soon, but I want to make sure that you do see a number like 10.0.something.something, that is filled in. It's not 0.0.0.0, and it's not 169.254 or something like that. It looks like this. And if it doesn't look like this, again, ask for help either in the live chat here on Twitch or in the Discord. If this all looks good, we're just going to make sure that that green done is highlighted and press enter. We're going to leave the proxy alone. If you know on your environment that you need a proxy, go ahead and fill in that information. But if you don't know what that is, you don't know what we're talking about, just leave it blank. Press enter and move on. We're going to leave the mirror address alone as well. This is where our Ubuntu operating system is going to be pulling down its updates. So we want to leave that alone. Okay. This is where we tell the installer where we would like the operating system installed. We are going to use the entire disk here, which is what this first option says, use entire disk. And then the VBox hard disk, you might see something that looks like that. This second option here, set this disk as an LVM group. We're not going to cover logical volumes in this course. That's kind of like a little next level, but it is, think of it as a software way to control your storage. For simplicity's sake, I'm going to ask that you move your cursor down to that option so that the little blinking cursor is under the X, and press spacebar. Turn that off. It won't do any harm if you set it up as a logical volume group, but I would prefer it to be off because it just adds complexity to the OS that we don't need for this course. So spacebar toggles those options, make sure that it's toggled off, and then move down to the done and press enter. It wants to confirm that you are asking for the right choices. So after that, it gives you a summary of everything that it's going to do. So it's going to make a new file system of about 30 gigs in my case. And it's going to create these two other partitions. It's going to take that virtual hard drive and split it up. You can see that if we look at those partitions, one of them is just 1 megabyte, which is called BIOS grub. We'll talk about what that is, but most of it, that 29.997 G in my case, that is where the operating system is going to go. That BIOS grub partition, that is actually going to be a section of the hard drive that the computer looks at first. When the computer turns on, the virtual computer turns on, it looks at that thing and says, hey, do you have an operating system for me? The BIOS, the grub partition says, sure do, here it is. This is where you can find it. And that's how the boot up process begins. That's a very simplistic view of the boot process, but basically that's what's going on. That's why we have those two partitions, one to get the process going and another one to actually contain the operating system. So we're going to go ahead and press done. That looks good. It asks us again, like, are you sure? Yes, I am sure I want to continue. It's red, so it's kind of scary, but we're good. We've made all the right choices here. We're going to press continue. Now, installation is going to get going, but we need to set up our user account to use this machine. You can set up however you want, but I'm going to set up that my name is Taggart. My server's name is HS21 for Hack Summer 21. And I'm just going to put in my information. Make sure you choose a good password. It will yell at you if you don't, so make sure you do. Your username, this is what you're going to log in with. This is just for decoration, basically. When you log into the machine, you're going to be using this username. So don't forget it, and don't forget your password. If you have a password manager like LastPass or something else, go ahead and put it in there for safekeeping. And go ahead and press done. Now, the next thing that it will ask you, this is really, really important. You do want to install OpenSSH server. So make sure your cursor is inside that box and press spacebar so that the X is there. We're not going to be importing an SSH identity, but that's it for there. The reason we're doing this is because we want to set up a remote access into the server that isn't just typing in this tiny little window. This window is tiny and annoying, and there are better ways to do it. So we're going to take advantage of that once we have all this set up. So install OpenSSH server and then choose done. Because this is a server distribution, it kind of has these out-of-the-box options ready for you right here in the installer. We could go crazy with this stuff, but we're not going to, with one exception. We are going to install Docker. So I want you to move down to the Docker option and press spacebar there, and then move down to done. Okay, so we are going to install Docker from here, make it nice and easy. We are going to use Docker later in the course, so go ahead and press done. And then that's kind of it for now. We're going to let the machine do the installing. You can even see here, in my case, it's installing kernel. So we're already seeing some of those terms that we've been working with. Giovanni, I know why installing Docker makes you happy. We have some history, friend. All right, so this is a good moment to, again, pause and in case anybody has any questions or clarifications. Shouldn't take too long for the installation, but you know, your mileage may vary depending on performance. This machine's a little bit of a beast, specifically because I built it to do stuff like this. Control byte. Never knew Docker can be installed at that point. Yeah, so quick some stuff on Docker and installing it at this point. The Docker install candidate from Ubuntu is going to be a little bit older than what you get from, you know, docker.io or whatever. So if you want the latest and greatest, you want to install from their repositories, but this is going to work fine for our purposes. Can you explain Docker? Well, I can, Gromit. We actually, an entire session of this course is dedicated to Docker. The penultimate course the penultimate session is about Docker. So we're going to go into it in depth. But basically, Docker allows another layer of wrapping applications. It's not a full virtual machine, but what we will be doing with Docker is taking applications that we want to be sandboxed and put them in this container so that it can run in isolation and also run with all of the dependencies that it needs to have on any Docker host we put it on, right? So we can have a single virtual machine, but multiple Docker containers on it running different applications and even running different versions of its dependencies. Socialist, that's a great explanation. Docker is a containerization tool. Virtualization has machines with multiple OS kernels. Docker has applications isolated with their dependencies, but a shared kernel. And again, stay tuned. In session 5, we're going to go all in with Docker. I probably should have done LXC too, but I have a long history with Docker, and even in this day and age of Kubernetes, which is a whole other level, I do still do a lot of work with Docker. I think it's still really, really relevant. So the last thing that's going to happen is that it's going to download and install updates for your machine, which I think is just handy, right? So even though you're getting that ISO from a point in time whenever it was built, the last thing the installer is going to do is download the latest updates. Is there a syllabus of sorts for HackSummer? There sure is. All you have to do is visit hacksummer.org. While we're waiting on the install, do I happen to know any data science learning tools, say for Kaggle? So if you had asked me this a couple of years ago, I would have recommended DataCamp. But then DataCamp had this whole thing where they were pretty misogynistic to some of their employees, so I don't feel comfortable recommending them. But it really depends on what you want to do with data science, Socialist. If you want to do R, that's kind of a whole thing. And if you want to do it in Python, that's also kind of a different thing. In both cases, though, I would say that I would point you to, let me get a, yeah. I would point you to No Starch. No Starch Press has what you need. Let's look for machine learning. No Starch Press is like my go-to. Yeah, this might be a good one, especially if it's in Python. So I would check out the No Starch Press offerings for like really anything, honestly. As a matter of fact, since we're talking about Linux, one of my favorite books is from No Starch, which is How Linux Works, which is a complete, like, super, super technical deep dive. I work on a social media branch that manages a community forum, needing to figure out data visualization.
Much effort, passion, or organization skills than what I've seen so far. Props to you.
Thank you, Control Byte. I really appreciate that. Thank you so much for the cheer. Alrighty. How's this install going? Done. So once the install and the updates are finished, you're going to see a reboot now. We'll click reboot now. Not click, press enter. We can't click because we don't have a mouse. And hopefully it'll reboot. Please remove the installation medium, then press enter. We can just press enter, and the machine will reboot. Now, as this thing is rebooting, the last thing that we're going to do today is we're going to set up port forwarding. Now, this is actually getting a little bit ahead of ourselves because we're going to be talking about ports and everything later, but I want to make sure that everybody has the ability to do this if they want to, because it's a much easier, a much more comfortable interface. So here's the deal. We set up that SSH server. That was one of the things we did on the install. SSH is secure shell. and it is a way to remotely connect to systems and access their terminal over a network. So rather than what we're looking at right here, this is like being in the data center, right? Being in the server room, air conditioners blaring or whatever, and you're like literally in front of the keyboard and the monitor connected to the server. And that's really not how things work these days, right? We don't have, I mean, it can be. As a matter of fact, I was at a data center earlier today, but most of the time we are dealing with remote systems, especially, you know, in the era of COVID. And so we want a way to remotely connect to those machines. How do we do that? SSH is the way. Now, we're not like super remote because we're talking about connecting from the host machine, your computer, and connecting it to the virtual computer. But even so, by using that SSH connection, we're going to have a much more comfortable terminal. We are going to have like scrolling and, you know, backspace and all sorts of stuff that we wouldn't have just typing into this monitor. So that's why I want to do it. All right, here's how we do it. To set up port forwarding, we're going to go up to the file option in the running virtual machine. So file preferences, and you're going to see this list of options here, right? For input, update language, display. But network is this actually where I want to be? Nope. Just kidding. Never mind. Oh, here we go. That's very funny that it was like machine settings. I'm sorry I blanked on that. We don't want to go to file. We want to go to machine and settings. That's the menu I was looking for. So here, this is all of the settings for the VM itself. And we're going to click on network. This attached to NAT, network address translation, is totally fine. We're not going to mess with that at all. What we are going to do is click on advanced and click on this port forwarding button. We haven't yet talked about ports, and so I'm sorry that we're doing this before we've gotten this foundation down. But basically, we're basically creating a tunnel from our host computer to the virtual machine so that traffic sent to a specific port, and we'll show how that works, is sent directly over to the virtual machine. And that'll allow us to SSH from our host over to the VM. That's how hackers get you. Yes, Nine, that's exactly right. Also a crucial skill for the EJPT. Okay, so this is where we set up our port forwarding rules. And I'm going to add a new port forwarding rule. I'm going to name it SSH. So just put a name there. And then in the host IP, I'm going to put 0.0.0.0 for reasons. But basically it's like any IP address on my host machine, anything that I'm coming from. Okay? And the guest and the host port I need to change. I would recommend something over 9,000, but that's mainly for Dragon Ball Z reasons. I'm going to do 9999 just so it's easy to remember. That's the port. Think of it as like a channel on the radio. And the guest IP, well, we know the IP address, but we're also going to try 0.0.0.0. And the guest port, this one has to be 22. Okay? So that's how that should be set up. Zeros here, 0.0.0.0 on both the host and guest IP. The host port, I'm going to do 4 nines. The guest port has to be 22. And then we're going to choose OK. OK again. Now, if you're on Mac OS, you can try this from your terminal app. If you're on Windows, you can do it from PowerShell, actually. And if you are using the Windows terminal or, using Windows subsystem for Linux, you could do it from there. I'm going to do it just from PowerShell just so everybody can see it the same way. But I am going to do it in Windows Terminal so that it is not small. So here's my Windows Terminal, and I'm going to zoom that text in. here's how this works. I'm going to SSH. It's a command built into PowerShell these days. If you're on a modern version of Windows, they finally added it. And we're going to do username at, and then the IP address or the host that we're trying to connect to. So in this case, I would do mttaggart, which was my username, at, and then we're going to do localhost. But here's the deal. Colon, nope, sorry, that's wrong, not colon. Dash P for port 9999, which says try to connect on SSH, but rather than connect on the default port of 22, we configured 9999 to forward over to the VM. So hopefully, if I made a mistake, this won't work, but hopefully this will work. Okay, great. And we'll get a message like this. It says the authenticity of blah, 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 blah can't be established. Are you sure you want to continue? Yes, you do. And to continue, you have to type YES and press enter. And if you go ahead and type your password in, it won't show up with asterisks or anything, but go ahead and type your password in. We're in, right? Feels good the first time you SSH into a machine. It feels like you did something cool. I still get that, little thrill every time I connect to something over SSH. And we are now in our virtual machine. We have successfully connected over SSH. And you can see that I'm at HS21, right? My whole prompt has changed. I'm in a Linux machine. You can see that we're getting this message about Ubuntu comes with absolutely no warranty, so we're on our own. Oh my god, Orbital Gun, thank you so much for the 5 tier 1 subs. That's incredibly kind of you. So here we are. Look at you with the Python. We can also toss some terminals in there. All right. We have reached the terminus for today's session. We have installed our Ubuntu VM. We've gone over the background of the Linux operating system. We've kind of set up everything that we want for this particular session. It's a good stopping point. So let's talk briefly about how to exit out of this. We'll just type exit. That brings us back to our regular PowerShell. So that's how we can keep that running. As long as this virtual machine is running, you'll be able to do that. If you power it down by clicking the X, you can save the machine state or just power off the machine. Either way, all you'd have to do is start it back up again in order for that SSH connection to work. All right. So again, I'm going to pause to see if there are any other questions before we close out for today. All right, well, again, if there are no other questions, so who does my graphics? Thanks, I do my graphics, Naiden. I really appreciate that. So if you want to take a look at I should actually just fix this in the web browser, huh? If you want to go see the entirety of the curriculum, you want to go to hacksummer.org. It's actually just a Git repository that it's going to redirect you to. But hacksummer.org has everything that you'll need to see the kind of the overview of the program. The Discord invite is in there in case you need it. And the syllabus is linked on there as well. And it tells you exactly what we're going to be doing for the rest of the course. Right, so we're going to be going through the command line, that's next. Vim, yes, we are going to spend a whole session learning that infamous text editor so that you can feel comfortable using it. We're going to go over networking, so those of you who are studying for Sec Plus or Network Plus, buckle up because we're actually going to go through a lot of the stuff that you need to know on there. We're going to do scripting and we're going to do containers. And then session 6 is just kind of a closeout. Where do we go next if you want to learn more? So that's going to be our Hack Summer program for this summer, for the next 5 weeks. All right. So with that, friends, I think we're going to call it a night. Thanks so much for hanging out. I really appreciate it. Please don't forget to join the Discord to continue the conversation or ask questions. Next Wednesday, we're going to be here, same bat time, same bat channel. We're going to be going over basics of the Linux command line. We're going to learn how to feel comfortable on the terminal, some basic commands that we can use, and very importantly, we're going to be setting up the challenges that use our Linux VM as the base. So there's a whole set of challenges and quizzes that you will be able to set up, and we're going to do that together next time. So until next time, friends, thank you so much for coming. I hope you've enjoyed session 0, I should say, of Hack Summer. Be good to yourselves, be good to each other, and I'll see you next time.